Yes, very good evening, students. It's the evening over here. Again, your mentor, your teacher, your guide, Dr. Kamalkant Sharma over here. As I discussed with you that we will discuss in detail about other kind of circuits. In the previous video, we discussed about combinational circuits. As I promised to you, those are having any queries still, they can check out my previous video of the combinational circuits. I also made one video on the the basic concept of digital electronics concepts. You can check out that video also. So I was not well actually, so that's why I break this video into two concepts. Before I start the video, let me discuss something. One student of mine, they are working on biomimicry. I hope you're aware about biomimicry. What is biomimicry is all about? Mimicry, you know very well. Bio is basically nature-inspired mimicry, and these kind of algorithms. I normally deal with nature-inspired algorithm. It is more. I'm more emphasizing for CSC students. When I talk about optimization, whether it's genetic algorithm, whether it's ACO and cloning optimization, whether it's PSO particle swarm optimization, or heuristic or meta heuristic algorithms, we have to understand, without dealing with binary values, without dealing with circuits, we are not able to make a clear objective of using combinational circuits, and we are going to use a memory in combination with a combinational circuit, a memory in a combinational circuit which will empower your sequential circuit. So when I talk about sequential circuit, I am talking about the basic concept of sequential circuit. In fact, a lot of concepts has been discussed in the previous video, but I will try to make it more general. When I talk about sequential circuits, we're talking about combinational first, and then we attach a memory with that particular combinational circuit. That memory can be volatile, that can be non-volatile. The input to that memory can be synchronized, can be asynchronized, it can be clocked, it can be pulse, right? We will discuss in detail in this video that what clock is all about, what pulse is all about, okay, how the pulse and clock are different. Might you see the ECG? In that particular, we're talking about pulse. If anybody saw the ECG, might be aware, we are having PQRS, four verticals, four terminals, four values on which we decide. Okay, so this is known as pulse, not a clock. So we will discuss in detail about this. What is clock? What is pulse? What is flip flop? How the different flip flops can be used? Okay, so let's start now. When we're talking about sequential circuit, we're talking about combinational circuit definitely, and the memory can be combined or can be connected in a positive or negative feedback. So when I talk about sequential circuits, you can see that the external inputs can be provided to the combinational circuit, the external output can be obtained. I hope you remember when I talk about your sequential circuits, I was talking about two concepts: the past value and the present value, the past value of the input and the present value of input. You can check my previous video in which I discussed that when I talk about present value, I'm discussing, I'm dealing with your what I'm dealing with, I'm dealing with combinational circuit. But when I talk with past value of input, I'm dealing with sequential circuits. So sequential circuits provide an output based on current and the past both, because a memory is attached. So how we can classify our sequential circuits? It can be event driven, it can be clock driven, or it can be pulse driven. On the basis of this event or clock, event is very random sequence. So normally we only emphasize on clock and pulse. So you can see it can be event driven. When we talk about event, as I told you, it is random, it is asynchronous. When it is clock driven, it has to be synchronous because clock has to be given to every flip flop or every circuit connected, cascaded, or coupled. And third is pulse driven, which can be cyclic or non-cyclic. So these are three different classification sequential circuits. Let's see if you're dealing with sequential feedback loop. Do you know that to retain the current state, sequential circuits depend upon the feedback, because then we decide the Q bar would be given or Q would be given. Now, very interesting over here that if we are dealing with Q, that means the output is same as input, then I am dealing with your positive logic. But if your output is not same as input, now when I'm saying output and input, I'm talking about its characteristics, its character. Now I'm giving 0, I'm getting output as 0. So that means the character is same, and if the character is same, I will say that the current and the past state is having a same clock. So the feedback in which we're talking about, the fraction of output is given back to the input. If the output and input are in same phase, we say the positive feedback, but if they're in opposite phase, we say the negative feedback. As I discussed with you in the starting of the video, even in the previous video, that we will discuss about latch and flip flop. So latch are nothing but uncontrolled circuits, or you can see they are dealing with signal levels, right? So latches basically can be controlled, but when they are controlled, so then how they can be controlled? When there's a master. Okay, so clock transition. So in flip flop, we are dealing with master slave combination, master slave configuration. In latch, it is not. So they are very sensitive, but yes, they are also asynchronous because no clock is there. Any flip flop, any latch can operate, and any any circuit can operate in any particular sense. There is no coordination among different circuits, so we name it latch. And flip flop are made from latch. This is latch. You can see the SR latch is there, in which the information, in which 0 0, you can see the 0 0 is given. It can be 1, it can be 0, it can be 0, it can be 1. The value keep on changing. It is not stable, so we name it latch. Okay. So there's a very summarized difference between latch and your flip flop. In latch, we don't require any kind of clock. Yes, in flip flop we require. Similarly, it's a level sensitive, where the flip flop is edge sensitive. We will discuss in the later stage of the video what we mean by edge and what we mean by level. But for instant, I can say that edge is basically dealing with trailing edge or rising edge. But when we talk about level, we are talking about highest level and lowest level. In the case of latch, the power requirement is very less, but in the flip flop it's high, and latch is fast operation but not stable, but flip flop is slow operation but it is more stable. So now let's talk about flip flop. It's a very basic digital circuit. One thing need to be understand, and that when we talk about flip flop, one flip flop carry 1 bit of information. I am again repeating, not 1 byte, 1 bit of information. And sometimes we normally, in some books, you can see the flip flop is also written as multi vibrator, bistable, because it has 2 states. Okay, it is not a single state, 2 state, Q and Q bar, because it can be 0, it can be 1 also. So these are the fundamental blocks, but they are clocked also, and when they are clocked, they are synchronous. When they are not clocked, it is latch. Okay, and both act as a memory elements. Remember, if no clock is given, the memory would be stored, but once the clock is given, the memory would be gone. So they're temporary storage. Please remember, they're not permanent storage, but they're temporary storage elements. Now we are having a four different type of flip flop. You can see in front of you. SR flip flop, JK, D, and T. SR basically, a set and reset flip flop. JK is a clogged SR flip flop, we can say. In T is a delay flip flop, and in T is nothing but toggle flip flop. In certain books, you can see D flip flop is also written as delta flip flop, but certain also authors or teachers or mentors, they also talk about delta flip flop. Well, well, more good to understand, but I just emphasize that you need to understand the basic working of the flip flop. Okay, these are some symbols. You can see, you can use NAND gate also, you can use OR gate also, but normally we use NAND gate, and you can see there's some symbols of flip flop. For the D flip flop, you can say we're having in one input. In T and D flip flop, we are having one input. In the SR and JK, we have two inputs. Clogged SR is nothing but JK. We can say to a certain extent, and SR is not having a clock. Okay, this is we have. Now in this case, you can see the simple working of the SR flip flop. Now I hope this is now clear to you. The level, lowest level is keeping at 0 and highest level is keeping as 1. It is totally up to me that whether I'm using a positive logic or negative logic. If I'm using a negative logic, then 0 would be high and 1 would be 0, or 0 would be high and 1 would be low, and vice versa. So you can say set and reset. So I'm giving 1 0, so output would be 0 1. So set Q bar as equal to 1. When it is 1 1, the output will be 0 1, no change. In reset, the Q bar has to be 0 and then again no change. In the case of 1 1, when I'm giving, it's an invalid condition, it is not available. Because Q and Q bar has to be opposite to each other, because bar is representing the inverted value. You can see I will try myself to best of my capability to tell you that yes, what edge and what trailing is all about. This is a rising and this is a falling, and you can see that we are giving 1 1 and this is 0 over here, and then it will go to 1, so there is no change. And then you're going to reset because it is converting from 0 to 1, so it is a reset. Again 1 1 is no change. 0 0 is the invalid condition, and 1 1 is unknown state, we don't know that. I hope this is clear. So this is the timing diagram or switching diagram for the SR flip flop. If I talk about JK flip flop, basically JK flip flop is designed when we say S and R is equal to 0. So these are two design problems. Anybody can ask you why we are designing JK flip flop. The SR flip flop suffering from two switching problems basically. Whenever the value of S and R, input S and R, is 0, it has to be avoided. And when the set or reset change occur, you have a select pin or enablement which is very high. Okay, so latching operation cannot be carried out because latching is basically 0 and 1. So for this, we are designing a JK flip flop. In JK flip flop, we don't have any right, no invalid condition as such as earlier in the case of SR. So normally SR flip flop normally also known as SR latch also. So this JK is basically a derived from SR flip flop, but the gated SR flip flop, in which no invalid condition is there. You can see over here. So we are providing a clock. It is same as SR, but we are giving a clock. So we are making a master-slave combination in which the clock will decide whether it is the turning on at the edge, rising edge or falling edge. Now you can see that whenever we are giving 0 0, memory no change, and at the toggle action you can see 1 1, it will be toggle. So you can see we can have a T flip flop also in this, and we will deal with the T flip flop. The toggle operation can be carried out. I hope this is clear. Similar in the switching diagram, you can see we are talking about rising and falling edge both, and in this we are getting a Q and Q bar instead of this. So whenever the J is equal to K bar, we're talking about toggle, and when we're talking about J is equal to K is equal to 1, we are talking about T flip flop. This is T flip flop. Very important flip flop we normally use. It is a toggle flip flop. So to avoid the occurrence of intermediate state, we normally use this toggle flip flop, and as you can already see, this is toggling is carried out. You can see the last one when the clock is at the falling. Okay, then the input is 1 1. The J is also 1, K is also 1. So you can see once it is coming 0 and then it's toggling. So this operation is basically leads to your toggle flip flop. It's like a switch. Okay, so changing the next output level to complement the present state output. I'm not going to the definition into it. So again, you can see this very simple one. But if you want to see from this other words, you can see that the feedback is connected to the AND gate itself. This is toggle flip flop. So we are having a flip flop logic diagram in which we are having a clock, and when you can see that Q and Q bar are totally opposite to each other, and the clock is basically controlling the output. Advantage, disadvantage, you know very well. This flip flop toggle input when the clock is triggered it inverts. So these kind of flip flops are basically used for counters. We will discuss later in other videos about counters, about memory interfacing. So they are good for counter. The state of flip flop is also known. Is known only when the previous state is known. So there are so many problems also, and they're not available in the IC. Right? So we only make this D flip flop using the JK flip flop. Even though when I'm talking about D flip flop, you can see the IC number is 74FC74. It is available on the Tinkercad also, and you can make it. So if anybody is interested in the practical implementation of D flip flop, we already made one video, but I think I didn't share on the channel, that the traffic lights can be made using D flip flop. If anybody interested, I can share that video on the channel also. So now let's go back to your D flip flop, in which in D flip flop we're talking about that's an AND gate, a bistable circuit, in which we want 0 and with the reset is also forbidden. So we are going to data latch, is also not data latch as I told you, delay, bistable, or simply D flip flop. Okay, so basically they are again constructed from the SR gated flip flop, but a inverter is connected. That means inverter means S and R being connected with the NOT gate. You can see now the S and R are connected with the combination of NOT gate, so that it can, whatever the input is given, say 0 is given as a set, it would be at R it would be 1. Okay, so that the delay can be carry out, and we can see basically the logic is basically blinking, like in the traffic light also we are using D flip flop. The basic requirement is D flip flop. You can see that in D flip flop we are toggling, and the switching diagram shows that yes, how the D input will work and along the clock, and the output will be obtained. We also have one thing, I hope everything is clear. Many times I was using the concept of master slave. When I'm saying master slave again and again, so I'm talking about the race around condition also. I hope you studied about, you read about the race around condition. We know in the JK flip flop, whenever the inputs are 1, okay, then the output will toggle whenever the clock is high. But the output is unstable, and this problem is based on condition. So we go with the concept of master slave JK flip flop, in which one particular condition will tell you about it, yes, whether in this we are talking about propagation delay. Okay, and anybody can ask you what is propagation delay. The propagation delay is the difference between input and output, and should be very less. In the delay flip flop, it would be high. So what we require, how can we remove this race around condition? Because if you remember the race around condition, the clock would be very high. So we can use master slave flip flop. We can use edge trigger, because edge would become the rising edge or falling edge will become after certain interval, and we have to increase the delay of the flip flop, right? So this is a master slave flip flop is a compared to JK flip flop. One will act as a master, and second will act as the inverter, and this circuit also includes an inverter, right? So if the clock, just keep it very simple. If the clock pulse is high, Then it is master. If the clock was 0, it is for slave. You can see that. So we are introducing a not over here. So everything is same. But yes, uh, if the clock is remain high for some time, then the output is uncertain. And this kind of condition is known as your race round condition, and we want to avoid it. Truth table or master is the combination. I hope this is clear to everybody. The last topic that we are going to discuss is the conversion of flip-flops. So you can see in front of you that the present state I already discussed in detail. So this thing I am keeping with, for you only. Just try it if you are able to understand this. If you are not able to understand, comment in a section, write in a comment section, and then I will explain it more convenient to you as per your requirement. But I hope I make it very clear that what D flip flop and how we can convert it to it. And I am again making it very simple. In the toggle condition, if you want to make D flip flop, see you want a set and reset in such a way that they are combined together, but the feedback should be provided given back because the toggle one. So the toggle will only come into the picture when we are talking about switch. In the delay flip flop, the SR and R connected with an inverter, it is not gate. And JK can be converted from SR using a clock. Okay, this is quite important. D flip flop conversion. So you can see that the present value. Remember, the present and past values are very important when you are going to convert from one flip flop to the flip flop. You can see that we are having a D flip flop, and you want a D flip flop. So what I need to use is, you can use exclusive OR gate, because you remember at the starting of the things, or the starting of the videos of the universal gates also, I discussed whenever the inputs are not identical, you will get an output, but whenever the inputs are identical, you won't get an output. This is what the concept we used in conversion of D flip flop, D flip flop. So in this video, what we discussed about the basic concept of sequential circuits. We also discussed that yes, what kind of circuits can be designed using flip-flop. We also discussed what is the difference between latch and flip-flop, the conversion of different flip-flops, the truth table of flip-flops. We also discussed that sequential circuit comprises of combinational circuit and memory. Without memory, we are not in a position to convert any combinational circuit into sequential circuit, and combinational circuits always would be a part of sequential circuit, right? So in this video we discussed about sequential circuit. In the previous video I discussed about combination circuit. You can check out the previous video, right? So any kind of query still you are not clear, you can write in a comment section, and I would be more than happy to answer. This is all from my side. I'm logging off. Any query beta, I would be more than happy to answer.